Hello, awesome students. This is Bert Dixon. Today we're going to be working with rational equations, solving rational equations. The section starts on page 453, but actually we're going to be starting our discussion on 454. So you can go ahead and open to 454 and follow along in your book as we go through these examples. So in the first equation, whenever we're solving rational equations, the first thing we want to do is recognize what x values can't we have in our solution. And so you'll notice if you rewrite this one, the first fraction can't be factored, but the second one can in the denominator. That's 2 times x minus 5. And so we have an x minus 5 in this denominator and an x minus 5 in this denominator. So we want to make sure that neither of the fractions have a 0 in the denominator for any x value that we want to plug in. So if we got a solution and we tried to plug it in and it made this denominator 0, then that's not really going to be a solution that works. So we call that an extraneous solution. When we get a solution that doesn't actually work, that's called extraneous. And so we see right away that x cannot be 5. So we call that an excluded value. It says here, identify any excluded values. So both of them give us the same excluded value, x equals 5. That doesn't usually happen. We usually have different excluded values for each fraction. In this case, they both come out with x equals 5. So we want to make sure that we don't accept x equals 5 as a solution. Okay, then moving into the how you solve the equations. For this first one, we're going to multiply both sides by x minus 5 to get rid of the denominator. So I multiplied both sides by x minus 5. And then to get rid of the denominator on the other side, we have a 2. So we multiply both sides by 2 in the top. And so both sides got multiplied by 2 and x minus 5. And so then the x minus 5s cancel as I showed here, and the 2's cancel on this side, and the x minus 5s. So what we're left with is just this 2 times x plus 7, and that turns out to be 14x, or 6x plus 14. And then on this side, everything cancels, so we just have 5x plus 17. So then you go on and solve that 2-step equation or 3-step equation and get x equals 3. Okay, so that one's already worked out for us. So let's try a new one that isn't already worked out for us. And so in example B, the denominators are all factored already. We see right away that the excluded value is 7. We cannot have 7 in any of our denominators, so we know that x cannot be equal to 7. And so then the process for solving this, I'm not going to try to fill in these blanks. I'm just going to work it out from scratch up here. So we have 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. And so I want to multiply by all the denominators that I see. They're all factored already, so I want to multiply each side by 2 and x minus 7. Multiply this side by 2 and x minus 7. And so the x minus 7's cancel when I multiply here. The x minus 7's cancel, and so I would have 2 times 2x minus 9. And then when I multiply here, the 2's cancel, and I would have x times x plus, or x minus 7. So I didn't cross anything out here because that thing is being distributed to both pieces. And it just because it cancels with one doesn't mean it cancels with the other. And then on this side, I do have the x minus 7s that cancel. I just get 10. And so now we have, if we distribute 4x minus 18 plus x squared minus 7x equals 10. So altogether, that's x squared minus 3x minus 28 equals 0. And so then if we factor that, x, 4 times 7 is 28, make the 7 negative and the 4 positive to get the correct middle term. And so our two solutions are x equals -4 and x equals 7. And notice that x equals 7 was on our list of excluded values, so that's called an extraneous solution. only x equals -4 will work. Okay, so here's one for you to try. Go ahead and identify your excluded values first, and then solve that equation. Okay, so if you're not done yet, go ahead and pause your video. But if you are done, if you already paused your video, we can multiply both sides of this equation by x plus 3 and x plus 6 to get rid of all the denominators. Okay, so I multiplied both sides by x plus 3, x plus 6. Here the x plus 3's cancel. I have 8x plus 48. On this side, the x plus 6's cancel. I have x plus 1 times x plus 3, which is x squared plus 4x plus 3. So moving everything to the left, or sorry, to the right side, I would have x squared minus 4x minus 45. And that is x minus 9x plus 5 equals 0. So we get two solutions from that, x equals 9 or x equals -5. And notice that our excluded values, x cannot be -3 and x cannot be -6. So neither one of these conflicts with the original problem, so those are both acceptable values. Okay, there aren't very many more good examples in the book, so I have some more that I'm going to have you can either write these down on, if you have open space in your book, you can do that, or you can just take out a piece of binder paper or graph paper, and let's work these ones out together. So this one, go ahead and copy this down and factor both denominators and then give it a try. So pause your video, press play when you're ready to see the solution. Okay, so if we factor the denominator on the right side, we have 2 times x minus 5. And so our excluded values, we see that x cannot be 2 and x cannot be 5. Otherwise, we would have zeros in the denominators. And so I can solve this now by multiplying both sides by x minus 2, x minus 5. And then those cancel, so I have 7x minus 35. Those cancel. I have 11x minus 22 divided by 2. So 7x minus 35 equals 5.5x minus 11. That would give us 1.5x equals 24. Divide by 1.5. X equals 16. And that is not an excluded value, so that is our solution. Okay, and one more for you to try. Go ahead and try example B. Pause your video, press play when you're ready to see the solution. This one, the denominators are already factored. So all we have to do is multiply both sides by the least common denominator, which would be 5x times x minus 7. And so here the 5x's cancel. I get 3x minus 21. And on this side, the x minus 7's cancel. I get 10x. So then I have 7x equals negative 21 and x equals negative 3. And looking at the original problem, our excluded values would be that x cannot be 0 and x cannot be 7. So this is our only solution. Okay, that's it for today's notes. Have a great day.